I'm really excited today to share with you a hot off the press 2025 study showing that we can reverse biological aging with simple lifestyle strategies. And the mechanism behind it is the strategies that we can implement are turning back our epigenetic clocks or our biological clocks. And this is really important because obviously if you're in the health space and you read the blogs and follow the main talking heads in the space, longevity is a huge topic these days. And part of longevity is distinguishing between chronological age, which is what your age is since you were born, right? You have birthdays, that's your chronological age. But biological age is what's the actual age of your cells, age of your body, your organs, your tissues. And the difference there is I could be 50 years old chronologically, but 43-year-old biologically. And you want to be as young as possible biologically, because biological age, as that increases, that's the aging that matters, right? So you could also be 50 years old chronologically, but 65 biologically, and that's bad news. And we've all seen that person, right? You've met somebody, you shook their hand, and you asked them how old they were, and they said they're 38, and in your head you're like, 38? You look like you're 54, or vice versa. They say they're 54, and you say 54. I thought you were 38. And the difference is in what their age is and what our expectation is the biological aging, and that biological aging is impacted by our lifestyle, our choices, and our environment and the environments that we're exposed to, and the impact of all of those factors on our epigenetics. And as a review, epigenetics is the study of the control of genetic expression. And that gene is being expressed due to inputs from above the gene. So lifestyle inputs, environmental inputs. So these are all very important topics. They're very sexy topics right now and very interesting topics because this is the nexus point between our genes and our environment, and genetic expression is the result of the environment interacting with our genes. So let's dive in. This study is the study that I'm talking about, and this was published just a month ago today, February 3rd, 2025, as you can see there in the bottom left. And this was published in the journal Nature Aging. And Nature is the most well-respected scientific research journal out there. So this is big time that this paper was published in such a well-respected journal. And you can Google this title and read the whole thing yourself, because you can see the lock in the upper right-hand side. You know, the lock you used to put on your locker in high school. It's unlocked, which means it's open access, and anyone can go and download this and read the whole thing. And so I'm going to switch from the PowerPoint to the actual paper so we can get into the meat. So here we are on the actual PDF of the paper, and the title of the paper is Individual and Additive Effects of Vitamin D, Omega-3s, and Exercise on DNA Methylation Clocks of Biological Aging in Older Adults. So this is a really exciting paper looking at key lifestyle factors and whether or not they influence our biological aging via epigenetics, which is the DNA methylation. So remember that methylating a gene determines the expression of that gene. Methylating a gene could turn it on or could turn it off, depending on the gene and the setup and everything. So we want to be good methylators, and methylation has been in the health sphere for years now. You may have heard of the MTHFR gene and the methylation cycle and methylated B vitamins, etc. There's lots of buzzwords for it and about it, but DNA methylation is massively important because that's influencing genetic expression. And depending on the genes we're talking about, in this paper, we're talking about genes related to biological aging. So vitamin D, omega-3s, and exercise. Three things we can all do, three things that are inexpensive, three things that are easy. If we do them, do they promote positive outcomes in biological age? If they do, that's a boon for all humans. So what did this paper look at? This paper, well, before we get into that, let's just look right here at the highlighted box. Epigenetic clocks are DNA methylation algorithms that combine information from measurements across your genetics to quantify variations in biological versus chronological aging. So what I spoke about a moment ago, there's chronological aging, which is how many birthdays have you had. There's biological aging, which is how young is your physiology. So again, I might be 50 years old by birthday, but 38 years old biologically. That would be beneficial and positive. I'm younger than my chronological age, so I'm healthier. Or flip side, I could be 50 years old by birthday, but 65 years old biologically because of the additive negative effects of choices and environment in my life so far. So this paper wanted to test the hypothesis of can vitamin D, omega-3s, and simple home exercise programs individually or in combination slow biological aging? So what they did, they looked at 2,157 generally healthy and active adults age 70 and older from 5 countries in Europe. So these are 70-year-old chronological patients. Okay, they've had 70 birthdays or more, and they're healthy and active. Okay, and what they wanted to test again was the effects of 2,000 IUs per day of vitamin D, 1,000 milligrams or 1 gram per day of omega-3s, and a simple home exercise program defined as 3 times a week for 30 minutes. And do these things individually or in combination over a 3-year period? How do they impact biological aging? And the biological aging was defined by follow-ups. They had blood work at the start and at 3 years. They looked at their DNA and their DNA methylation patterns and found the results. So we'll get to those results here. But just so you know, so the main outcome was does the D, omega-3s, and exercise slow biological aging? The secondary outcome was they wanted to analyze how different DNA methylation markers changed, how and whether they changed, because those are related to death risk. The faster we age, the faster we die, or the sooner we die. And they so they wanted to look at that as well. Let's go further here. All right. So what'd they find? Daily omega-3 supplementation reduced the age acceleration or pace of aging. So, in other words, daily omega-3 supplementation slowed biological aging. That's huge. It slowed your biological clock, so it gave you longer life, essentially, over this 3-year period. And we'll talk about how long here in a minute. The effects, so omega-3s did this. Then there are additive effects between if we had omega-3, the people in the group of omega-3 plus vitamin D plus exercise. So omega-3 alone will slow your biological clocks. And then if you take omega-3s and the D and you exercise, that does even better. The effects of omega-3 supplementation were somewhat larger for individuals with a baseline vitamin D level of greater than 20 nanograms per milliliter. So vitamin D research is so bad because they're always using less than 20 as low and greater than 20 as good. But if you go to your LabCorp result for your vitamin D level, you'll notice that the normal range for LabCorp is 30 to 100. So everyone below 30 is lab low. Well, this paper said the effects of omega-3 supplementation were larger for people with a baseline vitamin D greater than 20. Well, 21 is still terrible. 31 is still terrible. As we've talked about before, you don't want to be below 50, okay? And so probably nobody in this study had a level 50 plus, but that's beside the point. The point I'm trying to make here is that, well, yeah, if someone has sufficient vitamin D, then the effects of the omega-3 are going to be better because now that person has sufficiency and not just one key nutrient, omega-3s, but both omega-3 and D. And we've talked about the benefits of D many times. And I'll remind you that D itself regulates 2,500 different genes. So if you have a lab low D, your genetic expression is going to be way off. Your biological aging is likely going to be subpar. And so, of course, it makes sense that we want all nutrients to be optimal, not just in normal range, because as we've talked about, normal ranges are based on unhealthy people. So, what they find? Omega 3s alone reduce the rate of infection by 13%. You want to prevent infection? Make sure you're taking omega 3s. And remember, this paper, they only took 1 gram a day. 1 gram a day is better than nothing, but it's a subtherapeutic dose for most people. So if we took an actual therapeutic dose, all of these results are probably better. But with the subtherapeutic dosing that they gave these elderly people, omega-3 alone reduced rate of infection 13% and rate of falls by 10%. Well, that's huge. Whether or not this increases someone's biological or slows someone's biological clock, reducing a 70-plus-year-old's chance of fall by 10% is a massive boon because falls are a leading killer of the elderly. Not necessarily from the fall itself, but the effect of the fall that broke the hip that sent them to the hospital where they contracted the infection and died from sepsis. So if omega-3 can reduce infections and prevent falls, whether or not that slows your biological aging, that's still huge for the elderly. Omega-3s plus vitamin D plus a simple home exercise program of 3 days a week for 30 minutes, all combined showed a significant additive benefit by reducing pre-frailty by 39% and reducing incident invasive cancer by 61% over a 3-year period. Say wow. Cancer is the #2 killer to heart disease and quickly gaining on it. If we could reduce invasive cancer by 61% for pennies a day, a couple grams of omega-3, a couple IUs, 1,000 IUs of vitamin D, and some exercise, boom, 61% reduction, massive savings to the healthcare system, but more importantly, massive savings in life and health span. Blue box. The aim of the DNA methylation analysis in this study was to assess the effects of the interventions at the molecular level. So now we're talking about so we just said omega-3s will reduce rate of infection and falls. That's at the macro level, at the organism level. What does it do at the cellular level, the molecular level? What's it doing to the genes and your genetics? So looking at it that way, 3 of the 4 DNA methylation measures showed the clear signal for omega-3, highlighting a specific and notable epigenetic response. So omega-3s are not just winning on the outside for you in terms of, we'll call the outside the whole person level in terms of infection risk and fall risk, etc., but they're also winning on the deep inside by having a specific and notable epigenetic response. They have a notable influence on your genetic expression. That's huge because they're going to promote genetic expression of the good genes, not the bad genes, right? They're going to help prevent the expression of genes that promote cancer. Huge. This specificity is encouraging and supports the idea that targeted nutritional strategies can have distinct epigenetic aging effects. Boom. When you see news outlets saying that nutrients are worthless and this vitamin doesn't do that and you don't need that, take this drug. Show me a drug that slows epigenetic aging. You're not going to see one. Well, here's a very inexpensive natural thing that will have distinct epigenetic aging effects. So eat your wild-caught salmon, eat your wild-caught sardines, take your fish oil supplements. Moreover, the observation that individuals with lower starting levels of omega-3 exhibited larger epigenetic shifts further strengthens the case for personalized approaches. Again, this is the Captain Obvious moment here. Individuals with lower starting levels of omega-3 exhibited larger epigenetic shifts, meaning people who are more deficient saw more benefit. Well, duh. Omega-3s are part of the essential fatty acid umbrella of nutrients. The word essential and essential fatty acids means our body cannot make it. So unless you take it or eat it, you're not getting it. All right. So people who are deficient have larger benefit from repleting their levels. Makes sense because your body wants it, needs it to function properly. You provide it, you do better. This suggests that baseline nutritional status may modulate the extent of epigenetic responsiveness, emphasizing the potential of omega-3 as a targeted intervention to influence DNA methylation age and, by extension, biological aging. Boom. So again, this suggests that nutritional status matters, right? Nutritional status modulates the extent of your epigenetic responsiveness. In other words, if your nutrition's poor, your genetic expression is poor, and that leads to poor health. So again, these are things that we all, especially on this call, know intuitively, but it's great that the science is catching up for us, and it's great that it's in such a well-respected paper. Hopefully people pay attention to it. And if they don't, well, we'll benefit anyway. So you need to have optimal nutrition levels, and key nutrients from this paper are omega-3 especially, and then also vitamin D and exercise. The reason that I suspect the results aren't even better than what we're seeing, especially for the vitamin D, is that 2,000 IUs is a subtherapeutic dose that's not making a dent for anybody. So they needed to dose higher to get the impact. I bet if they gave people 10,000 plus a day in this study, they would have seen much larger clinical impact from the vitamin D. Furthermore, findings indicate additive benefits of omega-3 with vitamin D and exercise, extending the evidence from incident invasive cancer and pre-frailty to the molecular level. Additional support for an additive benefit of the 3 interventions comes from 4 of the 7 epigenetic biomarkers examined in our study. So again, additive effect, we're having synergy. There's not just one nutrient that we need. There's many, right? So the more that we can take and optimize the levels in our body of, the healthier we'll be. There's also a recent trial called the calorie trial that looked at caloric restriction for impact on biological aging, and that paper found that caloric restriction does slow the pace of biological aging. One key point there: caloric restriction is not starving yourself. It is a reduction in calories, but you are still getting sufficient nutrients. So you're not losing nutrients and being depleted in nutrition because you're starving yourself. You're still getting your nutrients, you're just reducing the amount of calories that you take in. The calorie intervention, or the caloric restriction intervention, induced a 2 to 3% reduction in pace of aging. So what if we ate less calories but still got optimal nutrition and exercise? Now there's more synergy. There's a 2 to 3% more reduction in aging. That's great. So what did this study find? This study found that over a 3-year period, implementing these strategies slowed biological aging by 3 to 4 months. Even small changes in biological aging, if sustained, may have relevant effects on population health. Or I would change that and say, who cares about population health? We're trying to impact the individual. We impact enough individuals, then yes, population health will be impacted. But 3 years of these strategies slowed biological aging 3 to 4 months. What if you did this for 10 years or 20 years or a lifetime? Now those 3 to 4 months accumulate and you're probably saving years of biological age. And that's how we can see centenarians, 100-plus-year-olds who look like they're in their 70s. And oftentimes those people are in the blue zones like Japan and other areas that are doing these things every day. Their cultures prioritize these things. Like Japan, they exercise, Tai Chi, okay, and other forms. They get lots of omegas because they're eating fish often. Vitamin D outdoors, sun exposure is important. So let's make a lifestyle out of it. So this is an awesome start with this study. You can see here there is no gold standard measure for biological aging. We analyze the best validated epigenetic clocks, which represent the current state of the art in the field. Again, this is a young field, it's a booming field, and this is a great start, a great paper to build on. And so as time goes, we'll get better and better and learn more and more and refine it more and more. But this is a great start. And the good thing about this is that you're not going to be hurt by taking omegas, vitamin D, and exercising. So get started. Our estimates of treatment effects are conservative. So again, this is conservative. It's likely impacting us even more positively than what this is showing. And remember, their dosing was conservative or subtherapeutic. So if you had proper dosing individualized to the person, you probably get better effects. Whether the treatments resulted in a persistent slowing of biological aging leading to the prevention or delay of frailty and chronic disease beyond 3 years is currently unknown. Again, this is the uh, first study of its kind, so they need to do longer follow-up, but it's great to see so far. For comparative context, recent analyses of vitamin D papers report a 3 to 6% reduction in causes of all-cause mortality risk with vitamin D supplementation. So again, we can take the omega-3s, we can take the Ds, we can reduce calories, and 6% plus 3% plus 4%, that adds up. Okay, that's 13% reduction or 13% extension of life. The epigenetic clocks we analyzed were developed to measure aging at the organism level and do not specify which organ systems may have been affected by the intervention. However, all three interventions were chosen to have diverse protective effects across multiple organ functions. So again, we don't really care. It'll be interesting to learn as time progresses which organs specifically are more or less impacted. But again, the whole body needs omega-3. The whole body needs vitamin D. The whole body needs movement and exercise. So just do it. As the body gets healthier, the organs will follow along with it. So this is a groundbreaking paper that's really exciting, and we can take a lot from this to support what we're doing. Our study bolsters the evidence from a randomized controlled trial for omega-3 as a single intervention and the additive benefit of omega-3 vitamin D and exercise on epigenetic clocks. Data from human clinical trials, including this study, are especially valuable for validating biological age indicators. So again, this is early on. So studies like this and others are going to validate biological age indicators so we can have markers eventually that we could test to say, hey, this is telling us directly about your biological age. In sum, our analysis provides evidence supporting the geroprotective or the elderly protective benefits of omega-3 supplementation and also suggests benefits of adding it to vitamin D and exercise. Our findings support the application of measurements of biological aging in general and later generation epigenetic clocks in particular in evaluation of interventions designed to slow aging and increase health span. So if you are out there and you're interested in longevity and quality of life and having as long a life and happy life as possible, then omega-3s, vitamin D, and simple home exercise are where you want to start. Because as we've said for years, lifestyle matters. Lifestyle influences your genes via epigenetics. And we have to be accountable and take action consistently over time to create the positive benefit in our health, in our quality of life, and now on our biological age. Let's open it up.
Bartemus, I have a question.
Uh-huh.
Could you repeat what the optimal dose is for D3 and omega?
Yeah, so it depends on the person, but the research for adults suggests a minimum of 4 to 6,000 a day. The lower your D, the more you can do to get it up to good. And then, sun exposure also matters there. But at least 5,000 is right in the middle of 4 to 6. So 5,000 a day would be reasonable and minimum for most adults. Omega-3s, again, you can test that in the blood as well. Um, and again, if you're not eating it, you're not getting it. So if you're not eating good sources, which would be wild caught fish, grass fed meats, and then to a lesser extent, chia seeds and flax seeds, then you're not getting the omegas you need and you're going to be depleted. So 1 gram a day, if you're not getting any, 1 gram a day will be helpful. But to get to optimal, up to 3 grams a day, which is 3,000 milligrams a day, is reasonable. Any other comments or questions on the paper?
I have one of those scales that like breaks everything down when you get on it, and it has a biological age on there. How
Uh-huh.
like how accurate is that kind of stuff?
Not very.
Okay.
Not yet. Yeah. It's cool and we wish it was, but it's not there yet. Um, the scales especially there are lab tests. Some labs have biological aging lab tests, and right now the kind of the plus or minus the standard deviation is about 10 years. So it's like they'll tell your biological age is 40 and plus or minus 10. It's like, well, that's not really helpful. So because that means you're somewhere between 30 and 50. So um, they're working on it and working on getting tighter. And there's some labs that claim they can get you to 3 to 4 year standard deviation, but so far it's not. I don't think it's ready for prime time yet. But you know this information, this is cool because it's not telling us what our biological age is. Because the what they did in this study was they looked at people's DNA from their blood and they've got, these algorithms to tell them that's not available to us as consumers right now. But the take home here is, hey, vitamin D and omega 3s and exercise are available to us. And so, if it's happening in some humans, it's probably happening in us too on some level. So we don't necessarily need to have the fancy genetic testing yet to know, hey, let's take the D and omegas and exercise. And hopefully we've been doing it already anyway, but we're getting that benefit.
Yeah. Yeah, I'm already doing that stuff. So hopefully it's working.
Yeah, same. Have been for
Dr.
years.
B,
So yeah.
sorry, it's Milena.
Hi.
Hey, I just wanted to follow up on the vitamin D question. So how often would you recommend we test our levels? And I asked because before the 3 month plan that I just completed, or since then, I should say, and taking 3,000 IUs a day, my vitamin D is now at 80. So, I mean, obviously, I don't want to go over 100, but that's a quick jump without really taking what you suggested earlier. So, how often would you suggest doing blood work to do that, to check that?
Yeah, thanks for the question. So it is, again, it's individualized to the person, their body weight, their vitamin D receptors, their genetics. There's a lot of factors to it. So to answer your question, or I will answer your question here in a moment, but what I do first is, in your case, for example, if someone comes in and they're subpar initially, then the first goal is to get them to optimal range, right? So in your case, it was let's shoot for 70. Well, can we achieve that? So let's say at 6 weeks you hit 70, then we could say, okay, well, let's continue you at 5,000 a day, and at 12 weeks we'll test it again. If at 12 weeks you're 105, 5,000 a day is more than you need at that point. So we'd want to reduce it and maybe look at your vitamin D in 6 weeks again. Or if we go back and we say at 6 weeks you're 70, okay, stay at 5,000. And at 12 weeks you're 74. All right, 5,000 looks like the maintenance dose that works for Melina to keep you in the optimal range we want you at. So we can follow up on your vitamin D in that instance in 6 months or whenever our next test is.
Okay.
So, we're working to figure out what is on an individual level. For Melina, 5K might be okay. For Annette, 8K. For Jennifer, 2. So my goal is to figure out what's the maintenance dose to keep the person in the goal range that we have for them.
Yeah, makes sense. Thank you.
So yeah, you're welcome. And as a piggyback on your question, so 70 is the goal. 80, 80 is not really something to worry about. Even if I've had patients, so 100 is where the lab cutoff is for lab high. I've had patients be 250 before because we were trying to dose them up from being too low, and they didn't have detoxicity. 250 isn't where I want them, but their body really responded to dosing that apparently they'd never had in their life. But it'll come back down. Detoxicity, if you're toxic in D, your serum calcium is going to go lab high, and that's very uncommon. So the goal is 70. If you were 80, that's okay. And even if you blipped into 100, what we'd say is, okay, let's reduce your oral dose for a little bit. Keep going in the sun or whatever, and we'll check it out at your next test. In general, it's far worse to be low than to overshoot it.